Hello, rising sixth graders. This is the third and, wait for it, final video for the summer. Please watch all of these videos carefully, deliberately, trying to make everything make sense. I guide you as much as I can, but it is your responsibility to make the math make sense for yourself. Please ask questions whenever there's the opportunity. And with these videos, if you don't get something the first time, you can go back and look at them again. Watch them with purpose. The last video closed with fraction multiplication, so let's look at decimal multiplication. And recall that there's a huge difference, a complete difference between adding and multiplying. We're going to multiply decimals completely differently from how we add or subtract them. Let's start with 5 times 0.12. You do not have to line the decimal points up when you're multiplying. So we can write this as 5 times 0.12 that way. Of course, the decimal point on the 5 would be at the end. If we had to place a decimal point, that's where it would be. And they're not lined up, but they don't have to be for multiplication. We pretend we're multiplying two whole numbers. We're going to do 5 times 12. 5 times 12 is 60. And now what about the decimal point? We count the number of digits that are to the right of the decimal point in both numbers. With the 5, there are no digits to the right of the decimal point, so we're going to count 1, 2 here on the 0.12, and then come down here, 2 digits to the right of the decimal point. So 5 times 0.12 is 0.60. Of course, that simplifies to 0.6. We did the 2 digits to the right of the decimal point. It just so happens that we can leave off that 0 and express the final decimal answer as 0.6. Now, why is this the case? Because these decimal numbers here are really fractions. When you have a whole number, you can write it as a fraction 5 over 1. So we have 5 over 1 times 12 over 100. This 0.12, of course, is 12 over 100. You see a 1 and a 2? The numerator is 12. You've got 2 digits to the right of the decimal point, so you've got a 1 followed by 2 zeros here. You multiply across the top and bottom. 5 times 12 is 60. Does that sound familiar? That's exactly what we did here. 5 times 12 is 60. And then 1 times 100 is 100. So there's 60 over 100. Of course, that does simplify to 6/10, the 0.6 that we got before. And here's the big takeaway for the understanding. Why do we count 1, 2 here and then go 1, 2 to the right of the decimal point in the answer? Because of these 2 zeros in the denominator of the 60 over 100. We're really doing 5 times 1200ths. And you've got those 2 zeros in the denominator. That's why we have the 2 digits to the right of the decimal point in the answer. I think a nice progression from the first problem, 5 times 0.12, what about 0.5 times 0.12? Well, let's just get a really good sense of what the answer is by realizing that 0.5 is a half, 0.5 is 5/10, which simplifies to 1/2, 0.12 is 1200ths. Multiplication, the word of is associated with multiplication. So what's half of 1200ths? That's easy. Half of 1200ths is, of course, 600ths. And that's our answer. How do we do the decimal multiplication as a decimal multiplication? Well, like that. We're still going to do 5 times 12 and get 60. And notice the decimal points are not lined up. They do not have to be with multiplication. You have to line the decimal points up when adding or subtracting, but not with multiplication. And please don't do this. Don't make them line up. Now, you can get to the right answer like this, but you're making it unnecessarily complex. 5 times 12, as I said before, is 60. Now, we look at both of the numbers we're multiplying, and we count the total number of digits to the right of the decimal point. And this time there are 3. So our answer has to have 3 digits to the right of the decimal point. Well, how do we make 60 have 3 digits to the right of the decimal point? We have to insert a 0 there and get 0.060. Of course, these zeros on the end of decimal numbers like that, they can, because of the great truth of equal fractions, they can be left out. This is 60 thousandths, 60 over 1,000, but that's the same as 6 over 100. So this is the same as 0.06. Now let's look at this decimal multiplication as a fraction multiplication. That's really what it is. 0.5 times 0.12. 0.5 is 5/10. Up there we thought of it as 1/2, but it is also 5/10, 0.5, and then times the 0.12 is 12 over 100. Multiplying across the top and bottom, we do that 5 times 12, which we already did. 5 times 12 is 60. This time we have 10 times 100 for the denominators. 10 times 100 is 1,000. That 1,000 has 3 digits to the, 3 zeros following the 1, which is exactly why we had to give our answer with 3 digits to the right of the decimal point, until we simplified it to 0.06. See, this 60 over 100 simplifies to, 60 over 1,000 simplifies to 6 over 100, which corresponds with that answer. So that's decimal multiplication. Don't need to line the decimal points up. Pretend you're multiplying 2 whole numbers and then count how many digits there are total to the right of the decimal point, and then make your answer have that same number of digits to the right of the decimal point. Why does that work? Because we're really multiplying fractions, and when we count 1, 2, 3, we're really counting the 1, 2, 3 zeros in the 60 over 1,000, because decimals are fractions. How about 3.5 times 0.8? Well, when you write those two numbers vertically, the decimal points do line up. It's okay if they do, they just don't have to. We're going to pretend that we're multiplying 2 whole numbers, 8 times 35, 40, we'll carry a 4 here, 24 plus 4 is 28. And now we count 1, 2 digits to the right of the decimal point in the 2 numbers combined. Our product or answer has to have 2 digits to the right of the decimal point. So we place the decimal point there. Once again, seems like I've done this more than once. We have that 0 on the end, which can be left out. But let's look at this decimal multiplication as a fraction multiplication, because that's really what it is. 3.5 is 35/10. A decimal number, the digits that you see without the decimal point are the numerator. So the numerator here is 35. There's 1 digit to the right of the decimal point here, so you've got the 1 0, the 1 0 following the 1, 35/10 times. Now you see an 8 here, so that's the numerator. The denominator is again 10, because you've got 1 digit to the right of the decimal point, so 1 0 here. We multiply across the top and bottom. We've already done 35 times 8 right here, and of course it's 280. 280, 35 times 8, and 10 times 10 is 100, so 280 over 100 is the answer. Now we already gave that answer as 2.80, and of course you can cancel a factor of 10 here. You can divide the top and bottom here by 10 to get 28 over 10, and of course that's the 2.8 that we also gave as an answer. So that's decimal multiplication. We're going to finish in this video, the final one for the summer, we're going to finish with fraction division, which one of my great mentor, my very important mentor in teaching middle school mathematics, I read a series of articles and books by a college professor by the name of Hung C. Wu. Professor Wu did something that is kind of unusual in mathematics. He wrote a sophisticated explanation of K through 12 mathematics, and I focused on the middle school part of that, to teach what's really going on. What I just did for you, originally I learned that from Professor Wu. It is the math teacher's responsibility to explain why, to explain why things work in mathematics. I often say, you may have heard me say this when you were in 5th grade, that the how is your responsibility. The how is straightforward. I'll say simple. The way, multiply as if they're whole numbers and count how many digits, that sort of thing. You go through that process. You do practice problems for homework and quizzes and so on, and that how should be something that becomes natural for you. But what about the why? That's what I try to do. And my approach is that when you understand the why, the how will be something that you own because it makes sense. Please make sense of the math for yourself at any point. And I'll tell you, any subject, any level of schooling, the one thing that teachers love more than anything else is a sincere question, because we know that that's what you need to do. You need to ask yourself certain questions if you don't understand something, and teachers are always happy to answer those. I might occasionally sort of throw the question back to you with a little suggestion, so maybe you could answer it yourself, which is even better. So just a little talk now about where we're headed in 6th grade math. The 6th grade textbook begins with a chapter on decimal operations. Add, subtract, multiply, divide decimals. I'm not going to cover decimal division in this video, not because it's hard, but just because limitations on time. And in the 2nd chapter of the 6th grade textbook, there is multiplication and division of fractions. No addition or subtraction because it is assumed that you learned that in 5th grade. We will review addition and subtraction of fractions. And with fractions, of course, we have to consider mixed numbers, which I don't think we have in these videos, but we've done them before, and we will continue to work with mixed numbers. Now, decimal calculations, you might be aware, can all be done on a calculator. So you might say, well, why do we bother? Because there's deep understanding of the underlying mathematics, particularly when you realize that decimals are really fractions, and it allows you to understand the mathematics. In the future, there'll be many times when you do decimal calculations with a calculator. It's not all there is to mathematics. You may have that idea. Mathematics is doing calculations, multiplying decimals, adding decimals, and getting a correct answer. There's way more to mathematics than that, way more interesting things in mathematics than just that. But it is important to learn them. So we're going to close this final video of the summer with fraction division. And sometimes I've seen social media and other situations with getting together with other math teachers for professional development. It seems that there's a lot of concern about fraction division, that it's hard, that it's strange, but Professor Wu taught me that it's not hard or strange at all. In fact, he wrote that once you understand fraction multiplication, and we did that in a previous video, that fraction division is just an afterthought. It's comes naturally and obviously, and that's what I'm going to try to convince you of in the remainder of this video. There are really two things necessary to understand fraction division. One of them is the great truth of equal fractions. That is everywhere. It is the single most important concept in middle school math, I think I will say. So that's part of what we'll need to do. And the other part of fraction division is a definition of division. Now, there are other definitions of division that we can use when we're younger with whole numbers, but those understandings of division, those definitions of division are not helpful with certain fraction divisions. But let's go back to something we're all familiar with. 48 divided by 6. Now, I wrote question mark here. We all know what that question mark is. Of course, it's 8. But why is it 8? Because that's the number you multiply 6 by to get 48. This definition of division is that every division is a question about multiplication. This quotient, it's called the quotient of 48 and 6, is the number you multiply 6 by to get 48. Now that you might not think that's a big deal, but when we get to the fractions, you'll see that it really is. So I'll replace, of course, the question mark with 8. The important thing is the because here. 48 divided by 6 is 8 because 8 times 6 is 48. Now, I'd like you to try this one. 10/3 divided by 5. Ask yourself, now let's look at the question mark right here, because what times 5 is 10/3? That's what I'd like you to think about. What do you multiply 5 by to get 10/3? 5 times what is 10/3? Well, isn't it 2/3? Isn't 5 times 2/3 10/3? Just listen to it. 5 times bigger than 2/3 is 10/3. So 10/3 divided by 5 is 2/3 because 2/3 times 5, we put a 1 under that 5, multiply across the top bottom, 2 times 5 is 10, and 3 times 1 is 3. So the definition of division is crucial. Now let's look at some other fraction divisions. And has anyone been wondering about keep, change, flip? We learned about keep, change, flip in 5th grade. We're sort of leading to why that works. That's what we're doing right now. Let's look at some examples. 2/3 divided by 5/4. You might recognize those fractions. We multiplied 2/3 and 5/4 in the previous video. Now we're doing 2/3 divided by 5/4. What's the quotient? Well, whatever the quotient or answer is, we need to be able to multiply that by 5/4 to get 2/3. Now let's think about this for a second. 5/4 is bigger than 2/3, right? This question mark has to be less than 1. 1 times 5/4 is 5/4, but that's too big. 2/3 is less than 5/4. So please convince yourself of that before you go on. Pause if necessary. The quotient here has to be less than 1. So let's talk about what it has to be exactly. And this is where the great truth of equal fractions comes in. The quotient up here that we're going to be able to get must be able to multiply by 5/4 to get 2/3. Well, the 5/4 has a 5 on the top and a 4 on the bottom. The 2/3 doesn't have those numbers. We want to get rid of that 5. So to get rid of the 5 here, when we're multiplying, we need to have a 5 in the denominator because of the great truth of equal fractions. These 5s will cancel when we multiply. Now, this is a division problem, but a division problem is really about multiplication. Now, we also want that 4 to go away. Because the quotient, our answer, must be able to multiply by 5/4 to get 2/3. We don't want that 4, so a 4 is going to go there in the numerator so that it will cancel with the 4 here. Now we want to end up with 2/3, so we have to put, I'll use the x for times up here. That is exactly the fraction that we need to multiply 5/4 by to get 2/3. But let's look at it this way. 2 times 4 over 3 times 5, and then times 5 over 4. Now these are all going to come into one big fraction. 2 times 4 times 5 over 3 times 5 times 4, right? This 4 will cancel that 4, great truth of equal fractions. This 5 will cancel this 5, leaving the 2/3. That's it. That's why fraction division is really, as Professor Wu taught me, just an afterthought of multiplication. Multiplication is the really subtle one that you have to take some time to understand. This is easier. Now, let's look at keep, change, flip. All right? To divide two fractions, keep the first one, switch to a multiplication, change to a multiplication, then flip that second fraction, and we get 2 times 4 over 3 times 5, or 8 over 15. 8 over 15 is the quotient. But this right here, the result of keep, change, flip, is exactly the fraction that we built earlier that does the job. Let me write it again down here. We said that 2 times 4 over 3 times 5 is exactly what we need to multiply 5/4 by to get 2/3. Because the 4's canceled, the 5's canceled, and there's the 2/3. This is why keep, change, flip works. Keep the first one, change the division to multiplication, and flip the second one, multiply, and you get the quotient of these two, but understand why. Multiplication is commutative. It doesn't matter what order you multiply two numbers in. Division is not. So this time we're going to do 5/4 divided by 2/3, the reverse order of the previous one. Now, this time, the quotient has to be greater than 1. The quotient is the number you multiply 2/3 by to get 5/4. Now, 2/3 is less than 5/4. So the quotient has to be greater than 1. 1 times 2/3 is only 2/3. Doesn't get you to 5/4. So the quotient has to be greater than 1. Let's, as we did before, build whatever the fraction is that we need to multiply 2/3 by to get 5/4, right? The definition of division, and then comes the great truth of equal fractions. What do you multiply 2/3 by to get 5/4? Every division is really a question about multiplication. Well, we don't want the 3, so on the bottom there, so we put a 3 on the top there. And we don't want this 2, which is on the top, so we put a 2 on the bottom. And we want to end up with 5/4 when we do the multiplication that this division is really all about. So we'll put the 5/4 there, times signs here. If you multiply this fraction by 2/3, you will get 5/4 because the 3's cancel. When you multiply them together, you'll have 5 times 3 times 2 over 4 times 2 times 3. The 3's cancel, the 2's cancel, and there's the 5/4. The quotient to the fraction division is literally just the fraction we need according to the definition of division. That's it. We build it. We build it ourselves. And ultimately, after you understand the why, which is what's going on here, you'll keep, change, flip, and you'll be confident in it. Let me show you the keep, change, flip. Let me keep this here this time. Last time I shouldn't have erased it. Let me keep that there. And now watch what happens when we apply keep, change, flip. keep the 5/4, change the division to a multiplication, and flip the 2/3 into 3/2. Now, look at that. 5/4 times 3/2 gives you this fraction, which is what we needed to be able to multiply the 2/3 by to get the 5/4. There it is. 5 times 3. 5 times 3 over 4 times 2. It's what we need to multiply the 2/3 by to get the 5/4. So our quotient this time, 5 times 3 over 4 times 2 is 15 over 8. Did you notice that? Do you recall that the quotient last time, when it was the other way, was 8/15? Well, now it's 15/8. That's not a coincidence. It always works that way. Division is not commutative, but when you change the order of a division, you get what's known as the reciprocal of the other answer. 8/15 the first time and 15/8 this time. And of course, 15/8 is 1 7/8. And hopefully you convinced yourself earlier that the answer had to be, the quotient had to be greater than 1, and it is. Let's develop the general formula for keep, change, flip. Let's take the two general fractions, a over b, divided by c over d. And if I didn't say this in the previous videos, I should have. Denominators can never be 0. You can never have 0 in the denominator of a fraction. This is a rule that never gets broken in mathematics. No matter what high level of mathematics you ever do, that'll always be the case. Denominators cannot be 0. So we understand that the b and the d cannot be zeros. And as it turns out, actually, the c cannot be 0 here either, because that's going to end up in the denominator of the quotient. Well, what fraction do we need to multiply c over d by to get a over b? This is the same thing we looked at with the fraction, the two examples from earlier. We're going to build the fraction that we need. What do we multiply c over d by to get a over b? Well, once again, here's a d on the bottom. We don't want that. So we're going to put it on the top so that it cancels. There's a c on the top. We don't want it because we want something that will multiply by c over d to get a over b. A over b is all that will be left when we do the multiplication. So c on the bottom. Now we want to end up with a over b, so we put an a there and a b there. This is exactly the fraction we need to multiply. The multiplication goes backwards. The quotient times c over d gives us the a over b. Now, why is that the exact fraction we need? If we multiply these two fractions, a times d times c on the top, and b times c times d, b times c times d on the bottom, the great truth of equal fractions tells us we could cancel the d's, cancel the c's, and there's the a over b that we need. This is literally the fraction we need to multiply c over d by to get a over b, and that's the definition of division. Definitions are so crucial in mathematics. And the great truth of equal fractions is extremely, extremely valuable and important. Let's break this a d over b c down. And by the way, that's the quotient, so I'll put it up here. So here's a formula for fraction division. But let's now come down here and apply keep, change, flip and see what happens. Keep the a over b, change the division to a multiplication, and flip the c over d so that it becomes d over c. When you multiply these two together, you of course get that, ad over bc, a times d over b times c. This is why keep, change, flip works. Let me just finish we'll get rid of all of this and then just show the entire keep, change, flip. So a over b divided by c over d is a over b, keep, times, change the division to a multiplication, and then flip the second fraction, d over c, multiplying across, you get AD over BC. Professor Wu taught me that division of fractions is just an afterthought. And that's what I hope to convey to you here. It's not complicated at all. And keep, change, flip. There are some teachers out there that don't like keep, change, flip because they say, well, the students are just going to do it without thinking. Well, you have to do a lot of things in math without thinking. Initially, you have to think about it, but you got to get to the point where certain things are automatic because you're going to be doing more complex and interesting problems in the future. So some of the things you learn earlier, you got to do automatically. And I used earlier the phrase own it. Well, I want you to always be able to do keep, change, flip for fraction division, but I'd like to think that you're going to own it because you understand why it works. So I think that's it. A little over 31 minutes. And I hope you enjoy the rest of your summer. We'll hit the ground running. You know I do that, right? Why not? You might have heard me say, I said this to at least one of my classes during the last week of school. Some of you might have thought, well, why are we doing math the last week of school? Well, it all depends on which word you emphasize. Do you emphasize the word last? Or do you emphasize the word school? Well, yeah, that's right. I always emphasize the word school. So the first day of school coming up, we're going to do math. Yeah. We'll smile, say hello to each other, and say things like, nice to be back. But I'm kind of greedy when it comes to math instruction. I want all of the available minutes. And I hope that at least someday, if not now, whoops, automatic lights. Hold on a second. I don't have much time left, but I don't want you looking at me in the dark. I hope that math can be a journey that maybe is not your particular favorite journey, but journeys are a big part of life, different kinds of journeys. And a big part of happiness, a big part of life is attitude. If you take the approach, if you have the attitude that math is a kind of a journey, there are discoveries which might give you now and then or frequently give you these moments of, oh, I see, that makes perfect sense. Well, this is how I want you to approach it. A lot of you love math. Wonderful. If it's not your favorite, though, give it a chance. Just give it a chance. So pretty soon we'll be saying welcome back and smiling at each other. and then we'll get right into the math. So enjoy the remaining couple of weeks of summer vacation. Rising sixth graders. Oh, I'll see you more often starting on August 28th as your homeroom and religion teacher. And I expect it to be a wonderful school year for all of us. Bye-bye.